Hello, everyone. Today is day 25 of Coding Every Day. Today is a Sunday, and it is February 9th at 1:12 p.m. So yesterday, I did word search, this problem here, where it's basically a word search, with a little bit different than the standard word search. And today I will be doing palindrome partitioning. So I did this problem like a long time ago. And I don't remember any of it. So I'm going to comment all of this out. And I'm going to delete this so we have a fresh start. Okay. So let's get started here. So given a string S, split S into substrings where every substring is a palindrome. Return all possible lists of palindromic substrings. Okay, so we basically have to like partition it in several different ways. So I guess like a brute force solution would be to generate every partition and then only return the palindromic ones, and I think that's what I'm supposed to do. So if we think about how to return every partition, so we have A, so we start with A, B. Okay, and let's say I equals 0. So at this index, we can either split it into 2 or not. So if we do split it, it'll be like this. And if we don't split it, it'll be like this. And now I is 1. And then we can either split it or not split it at index 1. So if we do split it, it'll be A, B. And also what we can do is, if the one that we just split isn't a palindrome, then we can just void the whole thing, I believe. So, okay, so if this is A, B, because we split here. And if we don't split, it's A, B. Okay, and this one, if we split here, it'll be A, B. And here it'll be, if we do not split A, B. All right, so now I think that's it because we don't really have a choice anymore. So my suggestion would, like my heuristic, I guess, would be, so after we split it, if that one isn't a palindrome, then we don't have to continue anymore. So for instance, if A here wasn't a palindrome, then we would stop because we can never alter A. Like all of these are going to have A by itself. And because it's going to have A by itself, that means it's not. If this was not a valid palindrome, then we should stop here because all of these will not be valid partitions. Okay. So in terms of the partition code, the data types of these. So I think that this would be, they'd all be lists of strings. Is that what it gives me? It just gives me a string. So I'm thinking we make each of them lists of strings, and because obviously here, like I equals 1. So maybe we could have like 2 pointers that kind of point to which position, like which part of the string and which index of that part. So let's say I and j. So here I is 0 and j is also 0. So it's the 0th element. So like this whole thing. And then j would be like at index here. So when we split it, I stays at 0. Or no, sorry. I goes up by 1. and j stays the same. Well, j goes reset back to 0, I guess. If we don't split it, then I stays the same, and j goes up by 1. All right, so let's see if that carries. So then I here, if we split it, I goes up by 1, and j stays the same. I guess j would go to 0. Here, if we do split it, then then I stays the same, but j goes up by 1. So then here, that would give us b. So in this direction, I equals I, and j plus equals 1. And in this direction, I plus equals 1, and j equals 0. Okay, so, and then if we looked here, so using this, what we would do is add 1 to I and keep j the same. So j would equal 0. So this goes to 1, and j goes to 0, which would be this one. And here, if we look at this, I stays the same and j goes up by 1. So I equals 0 and j equals 2. Right. So I guess if j is out of bounds, that would be our stop condition. Because right here, well, if either one is out of bounds, then that would be our stop condition. Because here it would say, yeah. Is there a better stop condition? Is it just I plus j? No, because here it's only 1, where all of these are 2. Okay, so let's imagine that we did one more step. What would I and j be after one more step? So here, I would be 3, j would be 0. So that's out of bounds, and then this would be I equals 2. So yeah, when it's out of bounds. All right. So I'll make a function called parts, which will, I guess, like cut maybe. So it'll cut the string. I'll call it part. Okay, so this is going to take in a list of string and I and j. And it will return nothing. It's not going to, yeah. It's going to add to a results list like that. Okay. So we could say, what should we call it? What could I call this? I guess like current. And we want to initialize it with call parts where current will be equal to current. We want s in a list like that, and then 0, 0. So the first thing we want to do is parts. Well, I guess we want to check if the first thing we want to do is split. We want to split it. Okay, so how would we convert? So if we have list 1 as ABC, and we want to get list 2 to A, B, C. Is there a built-in function that does this? Well, we can define because if you print L1 of 0, that will give you the whole string. So return type list of string. Yes, that gives you the whole thing. So we want is to split it. Okay, so this would be I. And then we want to split it at J. And it's guaranteed that it will be at least length 2. So it would be from like so should I insert something? So I think maybe I can make another function like split at I maybe, or split at. So it'll take in a list of strings. Okay, so I'm trying to think if we can append or if we have to insert. So for instance, that's throwing me off. Okay, so this one, we split it here. So could we just say remove? Yeah, because I'm just trying to generalize it. So for instance, we could have A, B, B, C, C like this. And if we want to split it here, so if it's in a list and that's one string, we want to get it into A, B, B, C, C like this. So I think what we can do is cut off this half and then append it to the list. Is that possible? I don't know if we have to insert it. Appending obviously is faster, because I don't think, no matter where the split is, you always just append this as the next one anyway. So I'm thinking, all right, if we have A, B, B, C, C like that, and we want to get it to A, B, B, C, C, then what we want to do is say, and so the place we're splitting at, so I equals 0, J equals 0, 1, 2, 2. So we want to say, right, would that be Okay, so we're going to say L1 of I of j. So L1 of I gives us this string, and we want to splice it like that, so it only includes the element after. Okay, so we could say like right half, and we can say L of I. Well, yeah, so we'll get it, and then we'll say L1 of I equals L1 of I up until j plus 1. And then we can say L1 dot append right half, and then print L1. Okay. So if I change this to a, I'll be right back. I think I'm onto something though. I'll be right back. All right, I'm back. Yeah, so I think I was onto something here. So let's say I have this as list 1, and I want to split here. So that means my I would be 1, and my j would be 1. So it should give me what I'm looking for. Yeah, perfect. So this is the code right here. So all I'm doing is grabbing the right half, setting it to just the left half, and then appending the right half to the overall list. All right, any edge cases or anything like that? Like if we have 0, 0 here, then this will give me A, B separated, right? What if I put 0, 1? What will that do? Nothing? Okay, I think this code is good. So, I don't think I need another function. All right, so so current is going to be equal to L1 in this case. So we'll say right half equals current. It doesn't have to be half, right, of right split equals current. Sorry, this, but not L1. And then we'll say current of I equals this right here. And then current dot append right split. Okay, so this is the splitting part, and then I have to undo this as well. So to undo this, we could say before split equals current of I. So this points to a string, which is immutable, so we don't have to copy it. I think we can change it like this as well. To me, it makes more sense like this. Okay. So if we think about this in terms of like backtracking, right? So we want to call the function again with, so when we split it according to our chart here, splitting it is to the left. So I goes up by 1 and j is 0. And then when we don't split it, I guess we could just pass before split? No, because we have to pass a list of strings. So here we can say current.pop and current of I equals before split, like that. So current.pop will get rid of this one, and then setting it to what it was before the split would undo it. So currents, and then in this case, I stays the same, and j goes up by 1. Okay, and if we do split it, we want to make sure, so here we could just say if current of I is a palindrome, then go down that branch. Okay. And we want to do this. So for instance, like that's if we cut A, we only want to call it again if that is palindromic. And same with this. Like we only want to go down this branch if AA is palindromic. Okay, so all right, so now I got to think base cases here. So if I is greater than the length of currents, or j is greater than the length of current of I, then I'll just say like out of bounds at current, and I think this would give us our answers, and it might be greater than or equal to, yeah, greater than or equal to, okay, so I don't need any of this anymore. Now I have to call the function. Here it is. Okay, so let me see what this looks like. Oh, we don't have is palindrome defined. Def is palindrome. And this takes in a string. So S. And palindrome is if it's the same forwards and backwards, right? So return if S equals S backwards. There's a better way to do this. While I is less than length of S divided by 2. If S of I does not equal palindromic, because you don't have to check the whole string. Okay, if s of I does not equal s of negative I plus so 0 should be equal to -1, and then 1 should be equal to -2. So is it negative I plus 1? Palindromic. I guess we could just return false here. All right, so let me test out this function. Print is palindromic. Okay. Is palindromic is not defined. Oh, is palindrome. Okay, so does ABC give me true or false? Is palindrome is not associated with a value. That's because I am doing it up here. Where's my console output? Returning. File too large. I'm not incrementing I. Oh, let me get rid of that. Okay, false. What if I do A? True. AB. False. ABB. False. That makes sense. I was like confused for a second. ABA. True. ABBA should also be true, and then I think that's probably sufficient testing. Okay. All right. So this works, but we are getting TLE on our main function here. All right, so let's see what's going on. So f string current equals what, I equals what, and j. All right. Oh, I'm not returning. Okay, so splits it out of bounds. So I don't really want this last split here. So when so if I equals, well, there could be something here. So I think j is a stop condition. So if j equals the length -1, then we don't want to do it. So if j equals 0 and there's one character. All right, so this is out of bounds. Yep. So then we go back to this one. Then that's out of bounds. AAB, AA. All right, so let me just see what happens when I say res.append current I want to see what this looks like. I'm seeing that some of them aren't all palindromic. AAB. So is this all the ways to partition it? AAB. Yeah, so this is all the partitions. Is there a way we know that we want to get out here? Not yet, because we could always like keep going and that could make it a palindrome. So is there anything that shouldn't be considered in this AAB example? Well, both of these are going to get calculated because A is palindromic, and then this doesn't check anything. So here, this is also palindromic. So this is valid. This is invalid. So is there a way that we can know it's invalid when we don't split? So I guess what we can determine is that if we've split, then that's palindromic. So we just have to check that if the last one is palindromic. So if current of -1 is palindromic, if is palindrome of current, the last element of current, then we append it. So this should only give us the palindromes. Yeah. And I think this works because my idea was we're filtering out anything. Like when we split, we know that we're filtering it out. So like everything here has to be palindromes or else we wouldn't have kept it when we've split. So we just that just leaves the last element. So we have to check the last element. Okay, so if we return results, will that work? Okay, awesome. So let me get rid of some print statements here. I'm just going to make a main function. Just so it's a little bit more readable. Oh, I guess it has to be global actually. Okay. So I'm happy with this. I think this was a great problem to understand backtracking, and also, you know, I've kind of gotten used to, so you'll like do something to the list, call it, and then not do something to the list, and then call it. So you can like add and then remove it, or in this case, I split it and then unsplit it, and then call it, and then just had these 2 pointers to identify where we're going to split it, because it kind of is like a 2D sort of situation, because it's a list of strings, which is kind of you need 2 pointers to identify that. That is Palindrome. I just want to see too if this works. Yeah, that works too. Honestly, so this code is faster because it basically does the same thing manually, except it only goes up until half. You don't have to look at the whole string. You can just go till half. Yeah, pretty happy about this one. I remember when I first solved this one. I think it said like September 24th or something. This was really challenging for me. It took me like the whole day, and I had this weird solution, which I'm curious to see what it was. But this definitely felt a lot cleaner and felt like I knew what I was doing a lot more. So I'm very happy about this one. Let's see where we're gonna go next. So yeah, so that's all of the backtracking problems. I might review combination sum, and subsets again, but yeah, that was great. Heap and priority queue. I think I failed this one, right? Yeah, this one was a headache. And then design Twitter, I could maybe try tomorrow. And then after that, I guess we'll start going to probably some graph problems next and some dynamic programming. I'm so excited for that, actually. Yeah. So that was today's episode. It was kind of a short one. Yeah, that's awesome. I'm making so much progress because I remember when I did this in September, it was like a real challenge. It was a real challenge. But now, because let's see, 157 to 75. So it's like 70, 80 lines of code, and this one's 35. Yeah, great progress, guys. All right, so I'll see you tomorrow, and I think I'll do the design Twitter one, and then on Tuesday we'll get started on graph problems or dynamic programming. So thank you very much for watching, and I'll see you guys tomorrow.